In this video, we're going to be talking about domain and range. Domain are all of the values that x is allowed to be, or all the values that your input is allowed to be. The range are all the values that the y's can be, or all of the values that the outputs can be based off of your inputs, right? So it's basically the solutions to all of your domain values, right? So let's practice finding some domains, right? So here we have find the domain of the following functions. So in our first function, we're being given a set of ordered pairs. Now, we're only looking for the domain, which means we're only looking for the x's. Where are the x's? So here we have a list, basically. We find all of our x's, and we're going to say, okay, the domains are going to equal -2, -1, 0, 1, and 2. Now, because it gave it to us in set notation, we really should write our answer in set notation. So what does set notation look like? Well, set notation would say that my domain is the set of x such that they are the values of -2, -1, 0, 1, and 2, and then I would close it. So that's really how we should write our answer because of the way the question was given to us. So in B, here we have g of x equals 1 over 3 minus x. So here to find our domain, what we're going to do is we're going to take our denominator and set it equal to 0 and solve for x, because we need to know what numbers x is not allowed to be, because we don't want a 0 in our denominator. So here our domain, is going to be that x equals all real numbers except when x equals what? And that's why we're taking our denominator, our 3 minus x, and we're setting it equal to 0. So I'm going to go ahead and I'm going to add x to both sides, and that's going to give me that 3 equals x. So if we had a value of x equals 3 and we plug that in, we'd get a 0 in our denominator, and that would not be okay. So we're going to take that 3 and we're going to put it right there, right? So that 3 comes right there. That's what x is not allowed to be, and that's going to be the answer to our domain. Let's box this one too. So let's look at our next one. Here we have for C that h of x equals the square root of x minus 16. So again, we need to know what values of x will kind of blow this up and make it not work. And we know that if it's a square root, we can't have any negative values. So a 0 is okay, but nothing lower than 0. So again, we're going to take that inside piece, we're going to take that, right? So let's start it off. The domain is going to be that x can equal all real numbers except, and we've got that stipulation. So we're going to take the x minus 16, set it equal to 0, and solve. So add 16 to both sides, and that's going to give us that x can equal 16, which means that if our value is that x equals 16, that's going to give us a 0. Now remember, that's okay. What's not okay is when it makes it a negative, right? So we think about that 16, and we go, okay, if I put the 16 in right there, I get 16 minus 16 is 0. And if 17 minus 16 equals 0, that's fine. Not equals 0, equals 1 is fine too. But if that number, if that x value drops below a 16, we're going to start getting negative answers. So our domain is that x equals all real numbers except when x is less than 16. Okay, and our 16 went right there. We kind of had to think about which direction that needed to go. Could it be bigger or could it be smaller? What was it allowed to be? So that's our domain. Let's take a look at another example. Here we have the circumference of a circle where c equals 2 pi r. Now here we have a little context in this situation, because we know that this is a circle, right? And so the input, the thing that's changing, is the r value. So the radius. So the question is, what is a radius allowed to be? How big is it allowed to be? Right? So can we have a radius of 0? If we had a radius of 0, would we even have a circle? And the answer there is no. So our value needs to just be bigger than 0. And it can't be negative because you can't have a negative circle, negative size of a circle. Size has to be positive. So here our domain is going to be such that R must be larger than 0. And that's going to be our solution there. Let's do one more example, but in this example, let's find the domain and the range. So here we have an example of f of x equals the square root of 4 minus x squared. So remembering what we did from up above, we know that we need to take our inside piece and set it equal to 0 to see what our domain is not allowed to be. So we'll go ahead and go 4 minus x squared equals 0. I'm going to add x squared to both sides. And that's going to give me 4 equals x squared. And from there, I'm going to square root both sides. And I'm going to see that I'm going to have value of x equals a plus or minus 2. So what that means is that if I have any number bigger than a positive 2 or smaller than a negative 2, I'm going to end up getting a negative inside of my radical, and that just simply won't work. So here for our domain, we're going to write that a little bit different than we did up above, because here our x has to live between negative 2 and 2. Now it's allowed to equal that because you can have a 0, but it has to live between those. Now remember that to find our range is basically all of the answers that you could get for your inputs. So if we take our x squared, and if we were to plug in a 0 value, that would give us 4 minus 0, which is, so let's see, 4 minus 0 squared, which would be the square root of 4, which is 2. So that's going to be the largest value that we can have, right? That's our largest. Now our smallest value, we already know that we have that set so that this number right here, right, our x, would be a 2. So I plugged in a 2, then I'd end up with the square root of 4 minus 4, which is the square root of 0, which is 0. So that's going to be my smallest value. So my range is going to be, my y has to be between the numbers 0 and 2. And we can check this to make sure that this comes out right by graphing that equation. So let's get our graphing calculator. And here we've plugged in the square root of 4 minus x squared. And we're going to go ahead and graph it. And we're going to make sure that we're set to zoom square so that we get an accurate representation. And we see that our answer here is showing us that the smallest value we can get is 0, and the largest value that we can get is the number 2. And so we know that we've set up our domain and our range to be correct. And so this is the solution there.